Hello guys, welcome to AR tutorials. Today is the day 2 of solving DSA questions, and today we have chosen 48 number of Leetcode question, that is rotate an image. Rotating an image is nothing but just 90-degree transformation of 2D matrix. What is 2D matrix? Is the two-dimensional array which has I and j index, I for the rows and j for the columns. Now we'll simply see how we can do it. Now as per this visualization, you can see the first row, that is 1, 2, 3, is converted into the last column. I repeat, the first row of the input matrix is converted to the last column of the output matrix. Similarly, the second row is converted into second last column, and the third row is converted to the first column of the output matrix. Now this question is really simple to solve. It hardly involves 2 steps. Now what we have to return? This question which we have to solve, we have to return vector of vector. In yesterday's video I have discussed what is vector in vector. If you have not watched that video, please go and watch for such small concept clearance. Now vector of vector is a big vector. Inside it we have to return small vectors. Thus each small vectors would replicate the rows and their elements. Now I'll tell you what we have to do. So first of all, we have to rotate our matrix to 90 degree. That is our image transformation. Here we have discussed as we have to make first row as the last column. The second would be the second last, and of course the third would be the first column. This simple mathematics is there. So it hardly involves two steps. The first is to transpose the given matrix. Now how to transpose the given matrix? I'll tell you. Now transposing the given matrix means we have to convert the first row into the first column itself, the second row as the second column, the third row as the third column. Now you have seen this is kind of similar what we are going to implement in 90 degree. Just we have to reverse the first row, the second row and the third row will get the 90 degree matrix rotation. Now I'll tell you the logic behind how we can transpose. Now transposing logic is that we can see these are the diagonal elements, and these are also the diagonal elements. You can see transposing does not occur on the this diagonal elements, but for a fact if we see this element and this element are swapped in transposed elements. Similarly this and this is swapped in this and this is swapped. So we can see that if we swap this, if we swap 3 with 7 and 6 with 8, we can get transpose easily. So when we do this transpose, after that if we reverse each rows if we reverse, we will get our 90 degree rotated matrix. This is so simple. Now we'll directly jump towards the code. Now for the code part, I have divided into 2 steps. First is rotate. Now what we will rotate, this is the default function. Now I have first calculated the size of matrix, then for the loop. Now the main logic lies in the loop. As we know, the diagonal elements would never be equal. So I'll loop this first loop from 0 to n minus 1, less than n minus 1, that is technically it's 0 to n minus 2. And the inner loop would be I plus 1, j would be I plus 1, because j would never be equal to I. So whenever I will be at certain position, the plus 1 position will be at j. It will never be at that similar position. And I have here taken n, j is less than n, because when I is n minus 2 at its threshold position, the one element preceding it would be always present. That element would be j. That means that I would never be equal to I. This is the simple condition, and just we have swapped inside the matrix of ij with ji. This is so simple. So what this step 1 will give? The transpose. Now we have got the transpose matrix in that matrix only. Now what we will do? We will again loop from I till n, and what we will do? Reverse. We will reverse all matrix of I with I. I represents rows. Now first what we will do? We are returning vector of vector. So first vector would be reversed, then second vector would be reversed, then third. Now this code I will run. All test cases, and I'll submit this code. And here we have achieved the optimal path. Thank you for watching this video. I'll request you everyone to please subscribe to my channel. I'm new to YouTube. I'm really learning everything every